The law of definite composition tells us that a particular compound will always be made up of the same elements. You can see over here on the right we have water, H2O, and the H2O is telling us that we have 2 hydrogens and 1 oxygen. H2, H2O, we'll leave the one implied, and we'll see lots more of that in later chapters. So a particular compound is always made up of the same elements. What else does it have? Well, it's going to have the same proportions. Those 2 hydrogens and that 1 oxygen will always be present in a molecule of water. And it doesn't matter what the source of that water is. So, if you take an acid and a base, H plus and OH minus, and you react them together, you're going to get water. Or, if you happen to go down to the shore and you grab some salt water, the water is still going to just be water. It's going to have salt in it as well, but it has no extra impact from the fact that it had fish urine in it, nothing like that. The water itself is still just water. The other things that are in the water make it different. But that's the only thing that makes it different. Water is water is water. It doesn't matter if that water happens in the vapor of a comet trail, or if you happen to find it stuck in rocks on Mars. The water molecule will still be water molecules. As long as you can separate it from the other molecules that are present, it's still going to be water. It's going to taste like water, it's going to drink like water, and it's going to react like water, because it is water. Now, I want to introduce a couple of concepts to reinforce this a bit earlier than the TRO textbook does. And I wanted to bring in the idea of mass fraction and percent by mass. We'll come back to this in the same chapter as it's originally presented, but I wanted to bring it up right now just so we can see and front load some of the information. If I have 10 grams of water, it turns out that it's containing 8.9 grams of oxygen, and it contains 1.1 gram of hydrogen. That means that for the mass fraction, it's going to have 8.9 grams of oxygen per 10 grams of water. So that means that the mass fraction will be 0.89. And if we turn that into a percentage, we just multiply it by the 100, and we put the percent unit on it, or percent symbol on it, I should say. And so percent by mass will be 89%. For hydrogen, it was 1.1 gram of hydrogen in 10 grams of water. So that means it's going to be 0.11, also known as 11% by mass. Now, you might be vaguely aware that a milliliter of water weighs a gram. You may have run across that fact before. It means that we need to specify which one we're talking about. Are we talking about percentages by the mass, or percentages by volumes, or percentages by another unit that we'll come up with later on in the course called moles? So we need to actually communicate what kind of percentage we're using. So make sure that when you write percent, you specify if it's percent by mass, percent by mole, percent by badgers, whatever. Specify the kind of percentage that it is.